Hello Internet students. Welcome back to the Arduino Basics tutorial series. My name is Adam. This is lesson number 18 where we're going to be controlling an RGB LED using an infrared remote. All right, let's jump right into the wiring diagram. I'm going to show you two wiring diagrams as to whether or not you have an IR sensor that's on a breakout board or one that's not. So we'll start with one that's not on a breakout board. I'm going to start with the RGB LED because this is something we've done before. So an RGB, remember, has one long leg, which is the anode, which is going to go to ground. Depending on the orientation of your LED, this might read from left to right, or it might read from right to left. So my anode here is going to ground. To the left of the anode, all by itself, is my red, which is going through a 220 ohm resistor into pin number 11. To the right of the anode is my green, so 220 ohm resistor, green into pin 10. And then finally my blue, which is 220 ohm resistor into pin number 9. So I'm using 11, 10, 9 for RGB on my board. For my IR sensor, okay, so this is a non-breakout board IR sensor. It's 3 pins. Reading from left to right is the pin, the control pin that's going into pin 7 on my Arduino, the ground, and then the 5 volt. And I'm using the 5 volt and ground rows on my breadboard. If you have one that's on a breakout board, it reads from left to right like this: ground, 5 volt, and then your control or your sensor pin, which is going into pin number 7 on our Arduino. So that's the only difference between the two wirings. So take a few minutes, get this all set up and wired, and then meet me back in the code interface and we'll start writing some code for this IR module. Here we are in our coding interface. We're going to start off by bringing in a library. So we're going to use the irremote.h library, which is going to allow us access to a lot of functions that are going to be required to make this IR sensor remote relationship work. Still above the setup function, we're going to bring in some pins and some variables that we're going to need for the IR. So we have a constant int called IR pin, which is pin 7. I have an IR receiver object called IR receive, and it uses the IR pin. And then I have a decode results variable. This is important because it allows the IR remote module to decode the results that we're getting from the IR into something that we can actually understand. Next, we'll set up our pins for our LED. So my red is 11, my green is 10, and my blue is 9. We'll set up a couple more constants and variables to use throughout our code. I have one to store the current red value, the current green value, and the current blue value, and I've initialized them all to 0 to start out. I'm going to bring in 3 more variables that I'll explain as we get into our code a little bit deeper. The first one is a Boolean as to whether or not the LED is currently on, and it is set to false. The next is actually an array of 3 strings, R, G, and B, called current color, and then an integer for color tracker, which is set to 0. We're going to be using these to toggle or to cycle through the colors on the RGB LED. Okay, an array is actually a list of 3 different strings, and we can access individual strings in this array using only one variable name, using box brackets, and then using an integer value for index 0 for R, 1 for green, or 2 for B. Current color box 0 is R, current color box 1 is G, and current color box 2 is B. And we'll use that notation to help us decide which color should be displayed on the RGB and to help us cycle through the colors later in our code. So now we're into our setup function. We're going to set up our serial for debugging. We're also going to enable our IR receiver. Serial monitor setup. To enable the IR, we call the IR object IRReceive.enable IR in, and IRReceive.blink13 is true. These are going to set it up and have it ready to listen on the right channels for IR signals. Next, we'll set up all the pins for the RGB LED to outputs. So I set my red, green, and blue LED pins to outputs. So the goal in this lesson is we're going to use the OK button on our remote to toggle the LED on and then off. And then we're going to use the left and right arrows to cycle through the 3 primary colors, red, green, and blue. So if we press the right arrow, it'll go to green, then blue, then back to red. If we press the left arrow, it'll go backwards. If the LED is already on, the color will just change on the fly. If the LED is off while I'm pressing the arrows, it'll still be changing the color in the background so that the next time I turn the LED on, I'll see whatever the new color is. That's the functionality we're going for. In order to do that, we're going to have to do a few things. We're going to have to figure out the hex codes for the buttons on our remote, which is one thing that we'll do. We're going to have to create some functions to kind of set the color values on the LED and a function to toggle the LED on or off. And then we'll use those within our loop function. So while we haven't written it yet, we're going to put a call here to the set LED function, and then we're going to go and we're going to write that function. In the set LED function, we're going to use our color tracker variable and our array of color values to figure out which color we're currently on, assign that to our color values, and potentially write it to our LED. So we want to do an if statement to check which color we're currently on. If current color, which is my array, in box color tracker is equal to R, that means the current color is red. Okay, then we want to assign the proper values to those three variables we said at the beginning. So our red value, our green value, and our blue value. In this case, we want our red value to be 255 and our green and blue to be 0. So we've now set the variables. But if our LED was currently turned on, we need to actually write those values out to the LED so that the color changes right away. Okay, so we would do that with another if statement. So remember, we have that Boolean for whether or not the LED is currently turned on. So let's use that. And it's really just as simple as saying if LED on. Because remember, this is a Boolean value, so it's always going to be true or false. So if it's true, then it allows the if statement to execute. If it's false, it doesn't. And now we're going to do our 3 analog writes to the RGB LED. So I'm going to analog write the red value to the red pin, the green value to the green pin, and the blue value to the blue pin. If the LED was on, it will do this right now. If the LED wasn't on, it still assigns the variables so that the next time we turn the LED on, the right color will show up. But it doesn't bother writing them out because we don't want to turn the LED on right now unless they push the OK button. So this is going to allow the colors to cycle for us. Well, it's part of the code that's going to allow the colors to cycle. We're going to essentially repeat this whole block of code, but as an else if for green and an else if for blue. So we can copy that whole block, come down, add the word else, and then paste it. Okay, and we'll change the R to a G. Red will now be 0, green will now be 255, and the rest will remain the same. Now we don't need to do the else if this time because blue is the only color left because we only put 3 colors into our array, R, G, and B. So if it's not R and it's not G, it has to be B. So I can just grab the code from inside and put it in here. Red value 0, green value 0, blue value 255. So this set LED method, here's what it does. It's going to assign our variables, red, green, and blue values, with the appropriate color values for the current position in our array. So if our array happens to be at 0, it's going to assign them for the red. If our array happens to be at 1, it's going to assign them for green. If our array happens to be 2, it's going to assign them for blue. Okay? So the next method we need to write is one to toggle the LED on or off when the OK button is pushed. So we're going to call this one toggle LED. Okay, so it's going to depend really on whether or not the Boolean LED on is true or false. So if LED on, which means the LED is currently on. And then else, which means the LED is currently off. Okay, so we're going to break it into 2 spots. What do we want to do if the LED is already on? Well, we want to turn the LED off. If the LED is already off, well, we want to turn it on. So if the LED is already on, we're going to print to the serial, LED turned off. We're going to write zeros to all 3 of the LED pins. And we're going to set the Boolean to false because now the LED has been turned off. And I put in a small delay. And then if the LED was already off, then we want to turn the LED on. We want to set the red pin to the currently stored red value, green pin to green value, blue pin to blue value, and set the LED on variable to true because now the LED is currently turned on. So we have our method set up that will allow us to toggle the LED on or off, and we have a method that's set up to set the color value of the LED depending on where we're currently at with our color index or our color tracker variable. We're ready now to head into the loop function. First, figure out how the IR remote works, and then use that IR remote to trigger these methods. So jumping into our loop function, we're going to start by making sure that we're reading things from the IR remote properly. And we're just going to print out values from the buttons that we get so we can understand what our buttons are actually doing. So we're going to do an if statement. The if statement checks the IR receiver module, decodes the results, and it's going to return true if it's decoding the results properly. That brings us into our if statement. We're then going to do 2 commands. We're going to do a serial.println results.value as a hexadecimal number, and then we're going to resume reading IR data. So all this is going to do is print to the serial what the current value is reading from our IR module. So it's not going to use our set LED method. It's not going to use our toggle LED method, but that's okay. We need to first learn how our IR works. So let's push this out to the Arduino. If I pull up my serial monitor, I shouldn't be seeing anything. Now, if I'm in a room that has a lot of IR interference, I could be seeing all kinds of crazy numbers coming up here. So you might need to create a kind of a shield over the IR sensor in order to shield some of that IR interference. So I'm going to press the OK button on my remote. And I see the value. Now, if I hold it down, it's going to show the value once, which is FF38C7, and then it's going to just show full F, hex values. Okay, so I'll press that again. You can see. Now I'll press my left and my right. Left, right. Okay, and I can map these, and I should just store this in a text document somewhere so I know for my remote what the OK value is, for my remote what the left, what the right, what the up, what the down values are. And that way I have them so that I can now jump into my code and actually get things working properly. Okay, so coming back into my code, I'm going to actually just comment out the line where I'm printing the codes out. I might want it later, but we'll set it aside for now. And we're going to write a new kind of statement. We're going to write something called a switch statement, which is kind of like a whole bunch of if and else statements. Okay, so it just simplifies the structure a little bit, and I just thought it'd be worth it to show you how they work. So a switch statement has to have a value to switch on. In this case, it's the results.value, which is a hex code. And then we get to put a bunch of cases. So if the value is a certain thing, if the value is something else, and so on. So they're called cases. So I'm going to set up a couple of cases here for OK, left, and right. Now the way a case works, you put a case and then you put the value. Now I need to put the 0x in front of the hex code to make sure that it compares it properly to the value coming out of the IR decoder. So for OK, this was my hex code. So what do I want to do when they press OK? Well, I want to toggle the LED, whether it be on or off. So I'm going to call my toggle LED method. Okay. I also want to print a debug statement to the serial monitor. And then you have to put a break. So the way a switch statement works, you set the switch statement value. You check one case against a specific value. If that is true, it runs this code, but it needs a break statement to avoid all the other cases. Okay, because you don't have the same if-else structure. So toggle the LED, print this out, and then break to begin it again. Okay. So if left is pressed, now this gets a little bit complex, so I'm going to try to explain it as I go. I need to increment my color tracker variable. So remember, I want it to be 0, 1, 2. And then I want it to go back to 0, 1, 2, 0, 1, 2, 0, 1, 2. Well, to do this, I'm going to use what's called modular arithmetic. Modular arithmetic just means when you divide by something, instead of looking at how many times it divides evenly, you look at what's left over. You look at the remainder. Okay, so for example, 5 divided by 2 is 2.5, or 2 and 1/2. So if you do 5 mod 2, you get that remainder of 1, that numerator of the fraction in the mixed number. Okay, that's what you get left with. So we can use mod operations to do this, because if I'm at 0 and I go up 1, I go to 1 and then 2, and then I want to go back to 0 again. So if I'm modding by 3, the only possible remainders are 0, 1, and 2, because it's either divided evenly by 3, which would be a remainder of 0, or it's 1 above, or it's 2 above, but it can't be 3 above, because then it's back to a remainder of 0, because now it's divisible by 3 again. So that's what we're going to use to do this left and right incrementation of the color tracker value. So I'm going to do color tracker equals bracket color tracker plus 2 mod 3. Now let's just think about this for a second. So if I'm at red, which is 0, and I press the left button, I want to end up at 3. Okay, so I need to add 2, which brings me all the way out to position 2. And I mod 3, because if I was also at 1 and I want to go back to 0, I would add 2 and then mod 3. If I'm at 3 and I want to go back to 2, I add 2 and I mod 3. We're just iterating through the modular arithmetic here. So this one is going to go to the left. So if I was at 2, it's going to go 1, then 0, then 2, then 1, then 0, 2, 1, 0. If I'm going to the right, we're just going to add 1 and then mod 3. Okay, because adding 1 and then modding 3 is going to take us 1 to the right. Because remember, there's only 3 possible numbers here. Okay, that's why adding 2 works. Subtracting 1 doesn't work the way that you think because of the way the negative values work. If you used absolute values and you did the subtraction, it might work out properly. But it works better by adding 2, which is kind of your max, 0, 1, 2 when you want to go left, and then adding 1 when you want to go to the right. So we increment color tracker. Now we're going to set the LED color. Okay, so now that we've set the color tracker variable, we're going to assign the color to the LED. So that's going to store it in our variables. Now, if our LED was already on, our set LED method is also going to change the color on the fly. If the LED was off, it just assigns the values so that the next time we turn it on, it'll have the proper color. I'll print a debug statement and then I'll break. And I do need to make sure I kept that IRReceive.resume outside of my switch statement. So this should work. Okay, and the modular arithmetic might be a little confusing. I will post a link in the description to a video by somebody else explaining modular arithmetic in a little more detail, just in case you struggle with that concept. Let's push this to the Arduino and let's see what happens. So I've pushed the code out to the Arduino, and first I'll just show you the button presses and then I'll show you the LED itself. If I press OK, it says LED turned on, OK pressed. My LED is currently on. If I press OK again, the LED turns off. LED on, LED off, LED on. Let's press the right arrow. Changes color. Now it doesn't like green because of my chroma key that I got going on. Green, and then blue, and then red. If I keep pressing the right, we'll see it cycles through. If I press left, it cycles through in the opposite order. And if I turn it off and then cycle the color, so it was green, but now it's red. I can cycle it to blue and then turn it back on. Right? So we can do the full cycle, turn it on and off using the remote. So there we go. I mean, that's the base lesson. There's a lot going on here. There's a lot to make sense of in the code in terms of structure, in terms of the methods and how they're working and what they're doing, in terms of getting the IR codes properly from the remote, all that kind of stuff. So take some time with this. Make sure you pause the video a lot to get all the code down, and then play with the code a little bit and see what you can get to make happen. Now that we're done the base lesson, we'll move on to the extension. Great job in the base lesson. For the extension on this one, again, just code modification so that you understand what the current code does and you can modify it. So all I want you to do for this is the left and right buttons that are changing the color, I only want them to work if the LED is on. If the LED is off, don't change the color values because it just gets confusing as to what color it's going to be when it turns back on. So only allow the left and right button presses to do anything if the LED is already on. So that's your extension. Meet me back here and we'll look at your challenge. All right, great job in the extension. In the challenge, we're going to add in the up and down arrows, which are going to adjust the brightness of our LED. So we can cycle through our colors. If I press the up arrow, you'll see it registers that the up arrow is pressed. And let's press the down arrow, and we see our LED dim. And again, and I have it set to 4 brightness settings, and then it's off. I can come back up. I can cycle through my colors while dimmed, and then I can turn it back off. This challenge is going to involve you setting up a float variable for brightness or an integer variable for brightness, and then using that in complement with the up and down button pushes to adjust the color value dynamically. Good luck with the challenge, and thanks for sticking with us through 18 lessons. I hope that you're starting to understand a little bit more about what's involved in writing software, as well as what's involved with the physical engineering side of all the things that we use every day. If you enjoy the videos, be sure to like the videos and subscribe to the channel to stay up to date as we continue to produce more content. Otherwise, I'll see you back here in lesson number 19. My name is Adam, and thanks so much for watching. Have a great day.